This is just one of the many beautiful swimming holes at Francis Creek. The rock walls are a pyroclastic flow that's been cut by rainwater and stream water. The unique holes in the rock are there because of how soft or hard the rock was when the water was flowing through, making them easy or hard to deteriorate. Hey guys, how's it going? Welcome back. Right now I am standing right beside, really close to a water hole. But what's really cool is the feature that's right behind me. Check it out. I don't know about you, but when I walk to swimming holes and stuff, I always wonder what kind of rocks are here? What does this look like? Well, this is a brecciated conglomerate, meaning some of the clasts are rounded, some of them are very angular. Angular is more breccia, rounded is more conglomerate. This specifically is a matrix supported brecciated conglomerate, which meaning these are clasts, the individual rocks, and the stuff in between it is the matrix. So you can see how many clasts there are via the matrix. Although some of the clasts are touching, there's still some matrix in between the clasts, therefore a matrix-supported conglomerate. Here's part 2 of the river conglomerate. This conglomerate will be classified as a fluvial-type system conglomerate from a very immature river. Conglomerates like this would have taken a lot of flow to move these rocks, and some of it is gradational, meaning larger clasts on the bottom and smaller clasts on the top. And then as we see in these pictures, it happened over and over again, giving us those layers of large rocks and smaller ones. So the river would rise, deposit a lot of material, and then digress. Higher up in this unit, this conglomerate is a matrix supported, seeing how there's clasts and then a lot of matrix in between them. One of the largest conglomerates in Arizona is the Gila conglomerate, and it can be mapped in large parts of the state. And you can see just how big this conglomerate unit is. Up on top of the hill, there's a pyroclastic flow, not to be confused with a conglomerate, but they look very similar. Hey guys, welcome back. This is Burro Creek Beach, a little tiny, beautiful swimming hole that stays all year round. The rock unit behind it is a pyroclastic flow with those weird little holes. It can often be confused for a conglomerate. The dark layer on top is basalt. The reddish layer in the middle is a rhyolite. And the white layer with a bunch of holes in it is the pyroclastic flow. This was cut by water flow, and the sand is mostly quartz and feldspar. This is basalt. Basalt is an extrusive mafic igneous rock. Basalt forms from rapid cooling of lava, rich in magnesium and iron. 90% of volcanic rocks on Earth are basalt. Basalt forms in columns, massive blocks, and sometimes swirls, like this one. Swirls are formed when the basalt comes out of the ground in its lava state and creates voids and refills itself with liquid basalt. As the basalt cools, it creates a beautiful swirling effect, almost like waves on a beach. Isn't this sandstone beautiful? I was on a several-mile hike and I just had to take a picture of it. Sandstone is comprised of sand-sized grains of rocks, minerals, and organic debris, and is cemented together with clays and silts. I found this sandstone particularly amazing because it has a depositional unconformity, those slanted rocks and the flat rocks on top of it. This shows a significant age difference in the sandstone. Sandstone gets that red color because of different levels of oxidation of iron in the sand. I picked up a piece of this sandstone for an awesome collaboration that I'm doing. This rock right here is basalt, a very common volcanic rock. Have you ever seen boulders like this and wondered why there's a bunch of bubbles in them? These bubbles come from escaping gases as the basalt was erupting. As it flows, gases get trapped within the rock. As it cools, these gas bubbles expand, and the rock hardens around each individual gas bubble, creating those bubbled lines, almost like petrified gas. Sometimes the basalt lava will have an overabundance of gas, creating partial or larger bubble lines. Thank you for watching. Please subscribe and like this video and share it with your friends.